Good morning, everyone. I wanted to apologize for the delay on this. I know I told you that I would get you a video with the word problems. I had some technical difficulties last night. Wanted to work through a couple word problems with you on homework one because I know we didn't get a whole lot of time to do that. So again, our process for solving word problems is read the problem, and then read it again. Read it as many times as you need to, as slowly as you need to, until everything makes sense and you know what you're told and what you're asked for. And then I want you to turn the words into math. I want you to take the information that you're given and make math equations with it. And if you need to use multiple variables at first, go ahead and do that so that you can make sense of the information. And then you need to make sure that you combine everything into one equation in one variable. Some of you may be able to do these two steps kind of at the same time, but don't take shortcuts unless you are 100% confident that you are doing it correctly. We don't want to take shortcuts unless we know where they go, because we don't want to get lost. So combine all of your math that you've created in step two into one equation in one variable. That way we can solve it. So go ahead and solve it. And then just make sure that you answer the original question that was asked, because sometimes the solution to your equation isn't going to be the answer to the question that was asked. All right, so the first one that I wanted to go through with you was Jane, Carlos, and Dale have a total of $109 in their wallets. Carlos has $6 less than Jane. Dale has 3 times what Jane has. How much money does each person have? If you need to pause it and reread it, go ahead and do that. Okay, so we've got 3 people here with a total of $109. One of them has $6 less than the other, and the third one has 3 times what another one has. Okay, and we want to know how much money does each person have. So let's start mathing this. So I'm going to take this first one and turn that into math. Jane, Carlos, and Dale have a total of $109 in their wallets. So that means if I add up all the money in each of their wallets, I should get $109. So I'm just going to say whatever Jane has plus whatever Carlos has plus whatever Dale has to be $109. So I'm just turning those words into math. All right, so now Carlos has $6 less than Jane. Okay, so what Carlos has is $6 less than Jane. That means it's whatever Jane has minus $6. And then Dale has 3 times what Jane has. That means the number of dollars that Dale has is 3 times the number of dollars that Jane has. Okay, that's all of the information that we're given. We've mathed everything that we have, and now we just have to figure out how to answer the question. Okay, so I can now put all of these together, right? The goal is to kind of combine these into one equation in one variable. Now, notice that this C, I have a connection here between C and J. So I could take J minus 6 and plug it in for that C. Similarly, this D also has a connection with J, so I can take this 3 times J and plug it in for D here. And when I do that, when I plug all of those things in and kind of combine all of these into one, I get that what Jane has plus what Carlos has, which is equal to whatever Jane has minus 6, plus what Dale has, which is 3 times what Jane has, is equal to $109. Notice when we put all of this together, I have one equation, and now I only have one variable. My variable is J here. If your brain doesn't like working with J's, rewrite this with X's instead of the J's, and then you'll feel right at home, and you can go ahead and work the problem. So at this point, this is a linear equation in one variable. We've been doing these, and I know how to solve this. We're going to combine like terms. We're going to simplify what we're given. So we've got 1j plus another j plus 3 more j's is a total of 5 j's. And then I have this minus 6. I don't have anything to combine with that, so it's going to stay here. And I have the 109 on the other side. Now to get j by itself, I'm going to keep the j's on one side. Anything without a j has to move. So I'm going to add 6 to both sides to move that. And I'm going to have 5j equals 115. And now to get j by itself, I'm going to divide both sides by 5. And I get j is equal to 23. Great, so we've solved the equation. Now, does that answer the question that was asked? So since j equals 23, remember j was the amount of money that Jane had. And so does that answer the question? How much money does each person have? So it starts to answer the question, but it doesn't completely. So in order to answer the question, Jane has $23. But then we also have to figure out what Carlos and Dale have. And so Carlos has $6 less than Jane. So that means Carlos has 23 minus 6, which is $17. And Dale has 3 times what Jane has. So Dale has 3 times 23 or $69. And that is how much money each of them have. You could add those together and you would get $109 just to make sure that you got it correct. Okay, I wanted to do a couple more with you as well. I want to do numbers 5 and 6 here, just so you have a couple more examples. So let's try number 5. Ryan needs to rent a car for the weekend. He can choose from 2 plans. The first plan has no initial fee, but costs 80 cents per mile driven. The second plan has an initial fee of $75 and costs an additional 30 cents per mile driven. How many miles would Ryan need to drive for the 2 plans to cost the same? Okay, so if you need to reread it, go ahead and pause the video, read it as many times as you need to work through that and figure out what this is saying. Okay, so Ryan's renting a car and he can either choose one of 2 plans. So either he doesn't pay anything up front, you don't pay anything for the rental, but you do have to pay 80 cents per mile that you drive. Or he can take the second plan, which basically means he's going to have to pay $75 up front just to take the car off the lot. And then he's going to have to pay an additional 30 cents for every mile that he drives. And he wants to know which one to pick. And part of that depends on how many miles he's driving, right? How far he's driving is going to depend on how much he pays for each of these. So we want to know how many miles he would have to drive for the 2 plans to cost the same. Okay, so let's start to math this. So let's start mathing the first plan. All right, the first plan has no initial fee, but it costs 80 cents per mile driven. So the cost of this is going to depend on how many miles he drives, right? So we're going to need a variable for that because we don't know how many miles that he's driving. So I'm going to come up with a variable. I'm going to use X because I feel like that's where we're the most comfortable. So my variable is going to be X, and I'm just going to make a note here that my variable is going to represent the miles that Ryan drives. It's going to be the miles driven. That's what my variable represents because that's what these plans costs depend on. Okay, so the first plan has no initial fee, which means he doesn't have to pay anything to get the car off the lot, but it's going to cost him 80 cents per mile driven. So I'm going to take 80 cents and multiply it by the number of miles that Ryan drives. Because if he drives 1 mile, he's going to pay 80 cents. 80 cents times 1. If he drives 5 miles, he's going to have to pay 80 cents times 5 miles. He's going to have to pay $4. So I'm multiplying the cost per mile times the number of miles will give us the total cost that he has to pay. Okay, so that's the first plan. And the second plan says that he has an initial fee of $75. He has to pay to just get in the car. And then he pays 30 cents per mile driven. Okay, so the cost of this second plan, just to take the car, is going to be $75, right? And then you're going to have to add to that 30 cents per mile driven. So again, we're going to do that 30 cents times the number of miles that he drives. And that will tell us this is the cost of the driving part, and this is the cost just to get the car off the lot. So we're going to add those together to get the total cost of that second plan. All right, so we've mathed these two parts. And then how many miles would Ryan need to drive for the two plans to cost the same? So in order to come up with my equation for this and answer the question, I need to figure out when the first plan is equal to the cost of the second plan. I want to know where these two are equal, so I'm going to go ahead and set these equal to each other. So my equation to solve here is 0.8 times x is equal to 75 plus 0.3x. All right. Now, this is the point where you can go ahead and solve this. If you like decimals, go ahead and move this guy over. If you don't like decimals, we can kind of do the trick that we learned in class. Since all of these really only go out to 1 decimal place, because this is a 0, so we won't have to worry about that, I'm going to multiply both sides of this by 10 to clear my decimals. Again, you don't have to do this, but this is something that you can do to clear the decimals. So however many decimal places, you're going to multiply both sides by 10 to that power. We've got 1 decimal place, we'll multiply by 10 to the first power, which is 10. If you had 2 decimal places, like if one of these was a 0.48, then you would multiply by 10 to the second, which is 100. You'd multiply both sides by 100 to clear those decimals. Okay, so we're going to multiply this. 0.8 times 10 is just 8. Then I'm going to have to distribute this guy. So I've got 750 plus 3x here. And now my decimals are gone, and I just feel better doing this without the decimals. Again, you don't have to clear the decimals, but if it makes you feel better and you can work the problem easier with it, go ahead and do it. All right, so I'm going to subtract that 3x from both sides to put all my variables on one side and keep anything without the variable on the other. And then I can divide both sides by 5, and I'm going to get x equals 15. And I'm just going to make sure 150, just kidding. Sorry, trying to do math in my head, and it doesn't always go very well. So I'm going to go ahead and check that because my brain is not wanting to work with me. Yay, 15 or 150. Okay, so x equals 150. So we want to know how many miles would Ryan need to drive for the two plans to cost the same. X equals 150, and X was the miles that he drives. So that means that he's going to have to drive 150 miles for the two plans to cost the same, and we have answered the question that was asked. So here the solution really was the answer to the question. Okay. The last one I want to work with you is number 6 here. The length of a rectangle is 4 inches longer than its width. If the perimeter of the rectangle is 40 inches, find its area. Again, if you need to pause it and read it again, go for it. Okay, so the length of a rectangle, I'm just going to draw a picture here. I've got a rectangle, it has a length and it has a width, right? And that's kind of how rectangles work. Okay, so we are told that the length of a rectangle is 4 inches longer than its width. All right, so let's math that. The length is 4 inches longer than its width. So the length is 4 inches plus the width. Okay, so we've mathed this part. And now we need to math this part. The perimeter of the rectangle is 40 inches. Okay, so the perimeter of the rectangle is 40 inches. Let's try to stick with this L and W um, to try to math this. So the perimeter of the rectangle. Perimeter is the length of all of the sides together. So if I were to find the perimeter of a rectangle, I would take the length plus a width plus another length plus another width. So together that's going to be 2 W's plus 2 L's is going to give me the perimeter, which is 40 inches. Does that make sense? The perimeter of a rectangle is this 2W plus 2L. That's how you find perimeter, and the perimeter is 40 inches. So hopefully it's clear where this guy came from. Okay, so we've mathed this guy too, and that's all of the information that we're given. And we need to find its area. Okay, so again, don't panic. We'll answer the find its area. We'll answer that question later. For right now, our next step, once we've mathed everything, is to put all of this together to create one equation in one variable. So I've got 2 equations and 2 variables right now, which is kind of like where we were up here. But up here, it was more clear how to put all of these together and just plug in what we had. So how would I be able to put these 2 things together? I've got L's and W's in both of them. And actually here I've got L equals, so this is actually okay. So L is equal to 4 plus W. This L is this L. So again, I can just take this 4 plus W and plug it in here to put these guys together. Okay, so when I do that, I'm going to get 2 W's plus 2 lengths. But again, our length is 4 plus W. So I'm going to take that 4 plus W and plug it in for the length. And that's going to equal 40. Now, if you hadn't had L equals or W equals here, if it had been like L plus W equals 8, you can always just solve for one of the variables and move the other one to the other side, and then basically work to get one of the variables by itself. Because when you do that, then you'll be able to plug it into the other equation. So in this one, it was solved for us. If it's not already like an L equals or W equals, go ahead and solve for one of the variables, and then you can plug it into the other one. Okay, hopefully that makes sense. But now that we've taken this 4 plus W and plugged it in for L, we've got one equation in one variable. W is our variable. Again, if your brain doesn't like that, go ahead and make it an X. So now to solve this, the first thing I have to do is simplify, and I got to distribute this out first. So we're going to have 2W plus 8 plus 2W is equal to 40. I'm going to continue simplifying here. I've got like terms. So I've got 4 W's on this side plus that 8 is equal to 40. So I'm going to keep all my variables on one side, move anything without the variable to the other side. So I'm going to subtract 8 to move that to the other side. And I'm going to have 32 over there. And then divide by 4 to get W by itself. So that means W is equal to 8. Okay, so what does that mean? W is the width of my rectangle, and so my width is 8 inches. Does that solve or answer the question that was asked? I'm trying to find the area of this rectangle. So the width is not my area. So now how do I answer the question? How do I find the area? Well, to answer this question, we have to compute the area. The area of a rectangle is length times width. So in order to answer the question, I need to know what the length is and what the width is. Well, I know the width is 8 inches. So my area is going to be whatever the length is times 8. But how do I know what L is? Oh, yeah, up here, I knew that the length was 4 inches longer than the width. So since my width is 8 inches, that means my length is 8 inches plus another 4 inches, which is 12 inches. So now I can take that and plug it in here. So my area is going to be my length of 12 inches times my width of 8 inches, which means my area is 96 square inches because inches times inches is inches squared. That is the area of my rectangle. All right, so hopefully that helps you see a few different kinds of word problems, and hopefully that's helpful for you. But again, the first thing you're going to do is make the words make sense and then turn them into math. Sometimes you'll only need one variable, sometimes you'll need multiple variables. And then take that mathing and turn it into one equation in one variable. And then solve it out and then make sure you answer the question that was asked. All right, I hope that was helpful. Have a lovely weekend, and I will see you on Monday. Don't forget, homework 1 is due on Sunday, August 20th at midnight.